Mathew Williams, Group 3. We'll be talking about manufacturing some technologies. The first one is friction stir welding. Anybody's taking friction stir welding next semester. This is kind of like what you're going to be seeing at NASA MSU. Friction stir welding, which is known as FSW, is a solid state joining process, meaning that the join materials are not melted and re-solidified. Instead, they are softened by heat generated from friction and then mechanically mixed to form a joint. Solid state welding refers to a group welding process that produces resistance temperatures, especially below the melting point of a base materials by joining without the addition of brazing filament metals, known as like fusion welding. The joining takes place without the fusion of base materials. Instead, the weld is formed by applying pressure and in some cases heat. As you can see from this picture, this is like your tool you use. You have a probe down here that stirs the metals together and it rotates in the forward position. That's pretty cool. Friction stir is an ideal technology to gain a better understanding of the essential engineering processes and systems. Some of the friction stir welding processes are joining process, forming process, forging process, extrusion process, heat treatment process, and statistical process. Friction stir welding equipment combines mechanical and electrical motion controls. They have open and closed control feedback loops, use electrical and hydraulic motors, spindles, and require material selection for intervals. Overview is external non-consumable pin tool plunges into workpieces to generate frictional heat. Rotating tool pressurizes the metal and creates a localized extruding zone around the pin. Pin tool shoulder applies forging force as the rotating tool transverses along the weld seam, generating a high strength solid state. No melting involved. So this is your effective zone, known as like a nugget. This is actually stronger than the material itself once it's finished joining, which is pretty cool. So usually if you put it through like a tensile machine and try to pull it, usually it'll break more in the metal pieces, not where it's formed. And the left-hand picture, you can see the different angles you can use: a square butt, edge butt, T-butt joint, a lap joint, multiple lap joints, T-lap joint, and a fillet joint. Another friction stir welding overview. The picture to the left is the adjustable pin tool friction stir welding, and then the picture on the right is self-reacting pin. Advantages of friction stir welding: mechanical properties is to improve strength, improve fracture toughness, improve ductability, reduce weld defects, microstructure benefits, parent material chemistry, ventilation from fill materials, and some applications is aerospace, architecture, marine, truck, and rail. So companies that use friction stir welding is Lockheed, SpaceX, NASA, Apple, Origin, Ford Motor Company, Boeing, and Honda. To the left are some test pieces used from friction stir welding, from using different types of metals. And the picture on the right is from a car manufacturer from Honda, where they friction stir weld aluminum and iron together. Another manufacturing technology is ultrasonic welding. Uses high frequency ultrasonic acoustic vibrations, which is applied by placing two workpieces that are being held together by pressure to create a solid state weld. The process involves vibrating one component in particular to another using a jackhammer or pivot. Some advantages: it's much faster, it saves production costs, produces a high quality bond that is clean. Disadvantages: large joints can be welded in a single operation. Expensive initial investment is required and additional tool costs. Here's some parts of the ultrasonic welding and how that is being run. Applications is usually aerospace aerospace, automotive industries, computer and electrical industries, and medical and packaging industries. Some safety is exposure to high temperatures, high voltages, and high frequencies can damage hearing. And these are some of my references that I got from NASA Issue and some other places.